Since owning a multi-material system like this one, it's pretty much become a thing of the past where I run out of material mid-print, or I've got like half-empty spools where I don't really know how much is left or if it's enough to do the print that I need. The reason is, now that I have a multi-material system, if I have, say, a print that needs 500 grams of material, but like this one in here, only has, I don't know, this much left, I know that I can start the print and it'll automatically switch to this identical spool of the same filament as soon as it's ready to go. Personally, I think this is a lot better because I don't have to wait for a filament sensor to trigger before I add the second spool. The print isn't waiting for me to actually do that spool change, and I can use every last gram of filament without any hassle or concern about interrupting that print at all. The problem is, of course, multi-material systems like this are pretty expensive and they can be locked down, again, like this one, to a specific ecosystem. But I don't actually need multi-material capability. What I want is the infinite spool capability, where it's just switching from one spool to another of an identical type. So the question becomes then, is it possible to get the continuous printing benefits of an AMS, but as a open source continuous filament system at a lower cost?
The other problem I've had recently is that my desk has been just a bit too small for working on 3D printers. Luckily, FlexiSpot have come to the rescue with their E7Q premium standing desk and sponsoring this part of the video. The desk they sent over is such a nice upgrade from what I cobbled together previously. The desktop is a massive 180 by 80 centimeters, which gives me plenty of space for having the streaming PC at one end and loads of room to work on 3D printers at the other. Honestly, that 80 centimeter depth is so useful for me, and for some reason barely anyone does it, so I'm really glad to have that. I had strict requirements for its appearance and usability too, so I needed it to look good on camera, not suck in all the light or be too dark, and just be nice and durable for working with. There are 8 different desktop colours in various sizes, but I chose this cozy feeling bamboo with a black frame. I was initially worried actually that the lifting mechanism might be a bit weak for lifting printers, since they can get quite heavy these days, and if I can't lift the printer, it might not be much good for me, but it has a load capacity of up to 300 kilos, so I could literally sit on it with a friend and it would still work fine. The height adjustability is a really welcome feature too, since now I no longer have to sit down all the time that I'm working on printers, and of course doing things like live streams, which will hopefully help my comfort and health in the long run. The assembly process was really easy too, and now I have this great workbench/desk for my studio. Check out the link below to enhance your workspace too.
I've been thinking about this material continuation system for quite some time now. For my workflow, it's really important because I don't use the multi-material benefits that this can bring, which also of course brings lots of waste every time you switch filament, but I do often use the material continuation, or just loading up multiple things so I don't have to change them as often. But I want to be able to use a similar type of system in terms of continuous filament printing on my open source printers, which I can't do with this. Recently, however, I was speaking to Kyle Hart of the Voron team and learned of a project which could be exactly what I want. A lower cost, open source alternative, which, while it's work in progress, could be exactly what I'm looking for. So today I want to take a first look at that system, print out the parts, have a look at it, see what the kind of cost overall comes to, and see if it's going to be worth it in the future as things develop.
The aforementioned project is the Primitive Infinite Spool System by Esoterical. This is a work in progress infinite spool continuous printing system designed to be simpler than other open source equivalents like ERCF or TradRack. Starting at the filament end, we have 2 spools. After each spool we have a filament sensor, followed by the stepper motor with extruder, and then another sensor. The first sensor tells the system to start loading the filament, such as when you push filament into the system to add a new spool. And the second will trigger when filament is loaded, e.g. the extruder has control of that filament because it's like within the extruder. This whole area here is designed into a unit called Dual Nightwatch. This is a compact dual Bowden style extruder with filament sensors before and after both of the extruders, based on the Voron Nightwatch, and a concept by Esoterical with the final design done by Kyle Hart. This unit can operate in 2 modes. either as two main extruders, basically two Bowden extruders, where each one would feed directly into the hot end. Or you can have it as a dual feed system, where each of these extruders feeds towards a main extruder, like normally situated on the tool head. In the second case, you could call them like a pre-feed extruder. When building this dual night watch, I really began to recognize how much wiring and stuff there is, because we've got 2 motors and 4 sensors all in this small kind of extruder housing. Next, we have a Bowden kind of Y tube. This feeds both paths on their way to the tool head, but I don't really have much to say about it. It's a splitter with some tube fittings. I think it's quite well designed. It splits into 2 parts, and then you sandwich them together. Next, we have the encoder sensor. This is optional, but pretty good, and allows for detection of filament jams. You could use an off-the-shelf solution, like the Big Tree Tech Smart Filament Sensor, or a more DIY design, like this one here, which is the ERCF encoder sensor. The ERCF is a Voron targeted multi-material system that can have up to 16 materials. This encoder sensor is kind of extracted from that design to be an independent item. The way it works is it has a sensor which notices the motion of the Bondtech gears as they are rotated by the filament. So sort of a reverse extruder, if you like. The filament moves the gears and the gears are read by the sensor. Next is the belay. This is needed when you operate the dual night watch as 2 pre-extruders rather than 2 Bowden extruders. So this was like pre-feed as opposed to the main extruder. This clever little design works on the basis that when feeding filament into a PTFE tube that's cut in the middle, the 2 facing edges of that cut in the middle of the tube will change distance depending on the length of the filament relative to the length of the tube. So, as you feed filament into the system, the gap widens and the sensor is not triggered. As you remove filament from the system, e.g. you start to extrude it out of the hot end, that gap closes, closing the trigger, and then causing the pre-feed stepper motor to add filament back into that kind of feed system. With everything connected together with PTFE tubes, you kind of start to get a sense of how long and stiff this assembly is, which might not be ideal in some cases, but of course it should be mounted rather than flying around between the tool head and the printer. So yeah, mount this bit and then just having a standard PTFE to the tool head. Seeing it this way also made me realize that connecting to the printer is not going to be super trivial. With up to 7 additional end stops, 2 additional stepper motors, and an encoder sensor, you need a board or expansion capability to handle this. When it comes to the firmware configuration, in the simplest terms, it's a bunch of clipper sections made up of filament switches, extruders, stepper drivers, and then quite a few custom macros that trigger based on the status of those sensors. Although much of it is pre-configured, of course, you do still need to set some values specific to your setup. Worth remembering though, if something isn't working or breaks, you will benefit from understanding those macros in order to fix it, and there are quite a few there. So of course, one of the major objectives here is cost. So I've done a quick cost analysis on the bill of materials to see how it stacks up. I've used some clone parts here rather than all genuine things, so of course, if you want the all genuine parts, like that will probably cost a little bit more. Overall, I've estimated the total part cost at around £72. Splitting this between the assemblies, we can see that dual night watch is the most expensive and accounts for about 80% of the total cost. Organising the BOM into these categories, we find that motors make up 50% of the total, with gears and tubes with fittings making up the other 40%. This is backed up by the parts chart showing NEMA 14 motors as the most expensive component, followed by a selection of BMG-based gearing stuff and Bowden fittings. Obviously, kits could be more expensive, as would be integrated electronics with less soldering and assembly and stuff like that, but I think the simplicity of the design is quite good and well optimized. I think the most obvious takeaway though is that the NEMA 14 motors are expensive in this application. It would be interesting to look at lower cost alternatives, since we don't necessarily need their rotational precision unless they're used as the main extruders. Overall, I'm really excited by what this project has to offer. There's certainly room for some optimizations here and there, but of course that's to be expected for a project that's still a work in progress. Hopefully the rest of the parts I ordered show up eventually, and I can build this out fully and give it a test on my Voron 2.4. As this develops in the future, I'll be helping where I can to make it as good as possible and make a setup guide when the time is right.
So what do you think? Are you going to try it? Let me know down in the comments your thoughts on the primitive infinite spool system and if continuous filament printing is exactly what you're after. Thank you very much for watching, and I'll see you in the next one.